Next up is entry number 9, Radhika Biyani from the Japan Advanced Institute of Science and Technology. Her presentation title is Virtual Reality for Virus X. Radhika? Okay, please start your presentation when you're ready.
In general, when I want to attend a conference in USA, I need a budget of more than 250,000 yen, almost 48 hours of travel, and the most exhausting part is to get the visa. And recently, I attended a similar conference by Zoom. So, no travel, no budget, no jet lag, and no physical exhaustion. And in fact, it was so simple doing it just by sitting in my room and even in my trousers. So, realizing the power of VR, that's virtual reality, is the new normal now. And this inspired the journey of my doctoral course. As we all know that we are in a virtual world today, and after the emergence of new coronavirus, we are deeply realizing this world. In my doctoral course, what I wish to emphasize is that we urgently need to prepare to face the next virus, that is the virus X, that may knock our doors anytime and anywhere from now. So, here the $1,000,000 question is how to prepare before we meet any virus X. My idea is when everything around us is being virtual and can be done just by a click on the computer, like the Google search engine, then why not our computers can provide a possible solution instantly for an unpredictable virus X in the future? In fact, till now, we have suffered from many virus diseases like the influenza, COVID-19, and finding an antivirus solution in our wet laboratories typically takes years. And such a long time plays a pivotal role in spreading the virus infection from endemic to pandemic. So we simply cannot wait and watch before we meet another coronavirus. Here is where my PhD steps in. I propose to utilize the power of AI, the power of IoT, and the power of supercomputers to establish a dry system and identify a super smart solution for the smart virus X. Here, I'm specifically interested in discovering biomedicinal compounds, which are made up of DNA, RNA, or peptides and are called as aptamers and can be used as antivirus agents. At present, aptamers are screened in a wet laboratory from a pool of millions of billions of candidates, and then a hit molecule is evaluated for its specificity, selectivity, and function to control the targeted protein of virus. Typically, a wet laboratory takes years of time. And for me, it took 2 years in my wet lab to find an aptamer molecule for Alzheimer's disease. So my idea is to perform screening of aptamers in just days by a cooperative integration of knowledge between the wet and the dry laboratory. What motivated me was to take the power of the virtual real solution to perform aptamer screening in computers for the virus X. Based on the molecular information that we acquire in the wet lab, we can develop a database, and then this can be processed to simulate the possible interactions between the aptamer candidates and the target protein of virus X. Once we have these molecular information, we can then optimize a hit candidate virtually and convert it into a fit candidate for the virus X. This will gradually help to build a new virtual platform for the virus X. Yes, so I strongly believe that predicting the future for virus X should be just next to the click of computers, and I'm strongly willing to challenge it. Thank you.
Thank you, Radhika. Let me ask you a question from Dr. Harayama. Are you collaborating with any researchers from wet laboratories? If so, what do they think of your idea?
So for my research, there will be two teams. Basically, one will be doing the wet part. So for the wet idea, generally, we are requiring a whole lot of time. Till now, experiments are done on the wet basis only. But because this process is taking years, and if we utilize the power of computers, and if we can collaborate with the information science people, with the computers people, maybe this can help us to speed up the process, which is taking years now, can be probably done in days, is what I think, and also the people from the website think.
Thank you very much.